review for the Edgenuity lesson, solving for angle measures of right triangles. So on this lesson, what we're doing is we are trying to figure out what the angle measures are. So in the previous lesson, we were solving for side lengths using sine, cosine, and tangent, and now we're going to use them to figure out what the angle measures are. So just so you know, these three things right here, sine inverse, cosine inverse, and tangent inverse, they undo sine, cosine, and tangent. So like right here, this little symbol here is called theta. That's what we're trying to figure out. When you use these inverses, what you're trying to do is undo the sine, the cosine, or the tangent function. They mentioned in the video that sometimes they are also called arc sine, arc cosine, and arc tangent. Those mean the same thing. Okay, so for this first example here, like I said, I am trying to get theta by itself. So we have to undo the sine function. And remember, your equation stays balanced as long as you do the same thing to both sides. So if I do sine inverse on both sides, those cancel, and all I'm left with here is theta. Now this is just something that we have on our calculator. If you're using a graphing calculator at home, you'll notice where sine, cosine, and tangent are. Right above them, you will see the inverse sine, cosine inverse, and tangent inverse. So I need to do sine inverse of 1/2. Oop, let me make sure that I'm in degrees. I am in degree mode. 30. So this theta here is 30 degrees. Okay, so for example 2, it says find the measure of angle A and the measure of angle B. So I'm going to start off first and make angle A here my reference angle. So when I do that, what happens is now I have to decide what is the opposite, the adjacent, and the hypotenuse. So over here we have opposite. That's not going to help me because I don't have any values there. This across from the right angle, this is my hypotenuse. And then this is my adjacent. So I was given values for the adjacent and the hypotenuse. So we have to decide how to set up the trig ratio first. So which of these three has the A and the H? This one. So that means I'm going to use cosine. So cosine of angle A equals adjacent over hypotenuse. Okay, so again, to get A by itself, I need to cancel out the cosine. So I'm going to use cosine inverse on both sides. So those cancel, and I get A equals cosine inverse of 7/10, which we can just figure out in our calculator. So I'm going to go second cosine, so cosine inverse comes up, 7 divided by 10, and we get about 45.6 degrees. Now, you could do another trig function to help you figure out B, but we also know that there's 180 degrees in every triangle. And if we know 2 of them, because remember we know this is 90 degrees, we can just do 180 minus 90 minus 45.6, and that will give us the last value, which is 44.4 degrees. Okay, so our next example says find the measure of angle G and the measure of angle H. So I'm going to use angle H as my reference angle. And the values that were given to me, if I'm using H as the reference angle, is opposite and adjacent. So since we were given the 2 values for opposite and adjacent, we have to decide which trig function to use. So which trig function has the O and the A? So that means we have to use tangent. So tangent of angle H equals opposite over adjacent. And you can simplify that if you want, but you don't have to. So to get H by itself, we have to undo tangent. And the way we do that is using tangent inverse. Those cancel, and I'm left with h equals, again, you can simplify if you want. I'm not going to, just so you don't get confused. And then from there, we just plug it in our calculator. I got 18.4 degrees. Again, we know that there's 180 degrees total in a triangle, so I can just do 180 minus the right angle minus 18.4 and get that the measure of angle G is 71.6 degrees. Okay, for our last example, this is a story problem, and there's an airplane at 30,000 feet. The distance the airplane is from the runway, measured along the ground, is 170,138 feet. What is the angle of elevation from the runway to the plane? So here's our runway, angle of elevation, so from the horizon looking up. So let's see here. If this is our reference angle that we're solving for, they gave us opposite and adjacent. So again, which trig function has the O and the A? This one again, we're going to use tangent again. So tangent of theta, which is kind of the variable we use when we're talking about angles, equals opposite over adjacent. So we're solving for theta, so that means we got to get tangent by itself, or excuse me, we have to get theta by itself and undo tangent. So I'm going to do tangent inverse on both sides. Those cancel. So then I can just go tangent inverse of 30,000 divided by 170,138. Oops. Oh, 10 degrees. So the angle of elevation there is about 10 degrees.